Imagine cities thriving with fresh water, baths overflowing, and fountains sparkling, all without the aid of modern pumps or complex machinery. The ingenuity of Roman water systems stands as a testament to their engineering prowess, a wonder that continues to captivate us today. The primary physics principles that enabled Roman water transport were gravity and the precise management of continuous flow. At its core, the entire aqueduct system relied on a consistent, gentle downward slope, carefully engineered to allow water to travel from a high-elevation source to a lower-elevation destination. The fundamental mechanism was the constant pull of gravity. Water, inherently seeking the lowest point, would flow naturally downhill. However, the Romans understood that this flow needed to be carefully controlled. Too steep a slope would create erosive, uncontrolled currents, while too shallow a slope would lead to stagnant water or no flow at all. They mastered the concept of hydraulic gradient, which is the measure of the slope of the water surface. By maintaining an incredibly precise and gentle gradient, often just a few inches per 100 feet, they ensured a steady, reliable flow that could travel 4 miles without needing any external power source. To achieve this remarkable feat, Roman engineers employed sophisticated surveying techniques and construction methods. They used tools like the quantities, a leveling instrument, to ensure the consistent downward slope across varied terrain. When faced with valleys, they built bridges and monumental arch structures to maintain the required elevation for the water channel. For obstacles like hills, they excavated tunnels, all while carefully preserving the critical gradient within the enclosed conduits, often lined with waterproof concrete. One fascinating application of their understanding was the inverted siphon. Instead of constantly building high arches, sometimes they would allow water to descend sharply into a sealed lead or stone pipe system at the bottom of a valley. The pressure generated by the height difference pushed the water up the other side of the valley to nearly its original elevation, where it could continue its journey along the gradient. This demonstrated a practical grasp of hydrostatic pressure and fluid dynamics, pushing the boundaries of what was achievable with available materials. Ultimately, the Roman mastery of gravity and hydraulic gradient was a triumph of practical science. Their ability to meticulously plan, survey, and construct these vast networks, ensuring a steady water supply for centuries, highlights a profound understanding of natural forces. It reminds us that even without complex theories, keen observation and persistent experimentation can lead to enduring innovations that shape civilizations.